So, question number 4, mechanics. A particle P starts at the point with position vector r naught. P moves with the constant velocity v meters per second. After t seconds, P is at the point with position vector r. So we have to find r. Our general equation is r is equals to r naught plus vt. So when we are finding r naught is given in this case, that is 2i plus velocity is I plus 3j, I plus 3j, and time given, that is 4. So 2i plus 4 into I plus 3, 4 times is 12. So we have 4, 4 plus 2 is 6i plus 12j. And it is same for every part. Let's try one more in this category. For example, we have question 4c part. So r is equals to r naught plus velocity into time. R naught is given for c part. R naught is, we have to find r naught in this case. So r is given, that is 4 plus 3j. So 4i plus 3j. R naught is unknown. Velocity in this case is 2i minus j. And time is given, that is 3. So 4i plus 3j is equals to r naught, and 3 2 times is 6i minus 3j. When we take this on the other side, signs would change. 4i plus 3j, you take 6 on the other side, that is negative 6i, and positive 3j is equals to r naught. So 4 minus 6 is minus 2i, 3 plus 3 is 6j. So the initial position is 2i plus 6j. Is this clear? F part is different. We need to find the speed. Now there is a difference between speed and velocity. Keep that in mind. So the general equation is r is equals to r naught plus vt. Now it says that r naught is 10 minus 5. 10i minus 5j. R is given, which is minus 2i plus 9j, and then velocity is unknown here and time is 4, and we have to find speed. So minus 2i plus 9j, and I'm bringing this r naught on the other side, becomes minus 10i plus 5j is equals to v into 4. So 2 and 10 minus 12i, 9 and 5 is 14j is equals to 4v. So velocity is equals to 1 by 4 of minus 12i plus 14j. Now it is your choice. If you wish to divide them, you can do that and give your answers as fraction or decimal. So 14 by 4 is 3.5. Now this is the velocity, and speed is equals to the magnitude of velocity, which is 3 square plus 3.5 squared whole square root. Which is 4.61 meters per second. Clear? H part says find time. So r is equals to r naught plus vt. R naught is given, that is minus 2i plus 3j, and then r is given, that is 6i minus 3j, and the speed is 4 meters per second, and we have to find time. speed is 4, that means the magnitude is 4, v is unknown and t is unknown. Let me just verify. T, r naught is there, r is there, speed is 4 meters per second. Okay, so rearranging 6i minus 3j plus 2i minus 3j is equal to velocity into time. So this is 6i and 2i is 8i, minus 3 and minus 3 is minus 6j is equals to velocity into time. When the speed is 4, so basically 8i minus 6j, speed 4 actually means that x square plus y square whole square root is equals to 4. So x square plus y square must be equal to 16. And if you just look at this gives you 8 square plus 6 square whole square root, it gives you 10. So basically it is 2.5 times. So if we take the velocity as unit, it is 2.5 seconds. So question number 5 says the initial velocity of the particle P moving with uniform acceleration is a meters per second square and u meters per second. So initial velocity is given, acceleration is given, find the velocity and speed of the particle after t seconds of these cases. So initial, acceleration and time. So we have v equals u plus at. First we were using this equation for the location, the displacement. Now we are going to use this equation formula for final velocity. So question number 5, a part. V equals u plus at, simple plug in. U is given, that is 5i in this case. Acceleration is given, that is 3j, and time is given, that is 4 seconds. So 5i plus 3 4 times is 12j. Velocity is 5i plus 12j. If this question would have asked for speed, we would find the magnitude. Let's see at E part. 5e. V equals u plus at. So velocity is equals to, initial velocity is 2i plus j, acceleration, sorry, that's acceleration, okay. Initial velocity is minus 3i plus 4j, acceleration is 2i plus j, and time is 5. So minus 3i plus 4j plus 5 2 times is 10i plus 5j. So when you simplify minus 3 and 10, you get 7i, 4 and 5, you get 9j. That is your final velocity. Question number 6. A constant force F Newton acts on the particle of mass 4 kg for 5 seconds. The particle was initially at rest. So initial velocity is 0. After 5 seconds, its velocity is this. Find F. So basically, when we are given with force and mass, we use this equation, F equals ma. Now F is equals to m. A could be replaced with v minus u over t. Change in velocity over time taken. Now we are going to plug in the values. Mass is 4. Final velocity is 6i minus 8j. It was at rest at start, so initial velocity is 0. Either you write it or leave it, no issues. And time is 5 seconds. So this is 4 by 5, that is 0.8 into 6 gives me, or let me just simplify first. 4 6 times is 24i, minus 8 4 times is 32j by 5. So 24 by 5i minus 32 by 5j. You leave it as fraction or as decimal, no issues. Question number 7. A force given acts on a particle mass 2 kg given. So force is given, mass is given, initial velocity of the particle is given, and how far it moves in 3 seconds. So we have initial velocity, we have time, force, and mass. Let me bring this here so I have more space to write. 2i minus j is given, mass is equals to 2 kg is given, time is equals to 3 seconds, that is given, initial velocity u, that is I plus 3j, and we need to find how far it moves. We need to find the distance. So when I use this formula, F equals ma, force is 2i minus j, mass is 2 kgs, and acceleration is final velocity minus initial velocity divided by time taken. So 2i minus j is equals to 2 mass, final velocity which is unknown, initial velocity is I plus 3j, make use of brackets, and time is 3 seconds. So I'm solving for v, the final velocity. So we multiply with 3 on the other side. 3 2 times is 6i minus 3j, and 2v, this is minus I into 2 minus 2i, minus 3 into 2 is minus 6j. 6i minus 3j, you bring these two on the other side, is plus 2i plus 6j is equals to 2v. So 6 plus 2 is 8i, minus 3 and plus 6 is plus 3j is equals to 2v. So my velocity is 4i plus 1.5j. Okay, now there is another formula which we can use, that is v square minus u square is equals to 2as. I have v, I have u, I have acceleration, and I can find the displacement. One thing or the other could be, we can use s equals vt, where v would be used as average. So initial and final, if I add these two, that is I plus 3j plus 4i plus 1.5j, and divide it with 2 to get average velocity. So 4 plus 1 is 5i by 2, and 3 plus 1.5 is 4.5. So 4.5 by 2 is 9 by 4. 9 by 4j. So I have the average velocity. I have the time. Time is 3 seconds. So for this average velocity, I need the magnitude to change it into speed. That is 5 by 2 squared plus 9 by 4 squared whole square root. So square root 5 by 2 square plus 9 by 4 square, I get 3.363. I also have the exact form, which is square root 181 by 4. Now you have the speed. So displacement is equals to speed times the time. So it covers a distance of 10.09 or approximately equal to 10.1 meters. Clear? Question number 11. At 8 a.m., two ships A and B are at R is given and RB is given. Their position vectors are given from a fixed point P. Their velocities are VA and VB respectively. Write down the position vector of A and B t hours later. So let's write it here. We may need it for the later half of the question. So write down the position vectors of A and B t hours later. So it would be the new position is equals to old position plus VT. So RA is given, that is I plus 3J, and V is as it is in V, A which is 2I minus J, that is given. So 2I minus J and T hours later, so in form of T, this is the answer. And for B, the position would be RB plus VT. This is A, this is B, and RB is given, that is 5I minus 2J. Velocity of B is given, which is minus I plus 4J and T. B part says show that T hours after 8 am, the position vector of B relative to A is given by this. So position vector of B relative to A, we will subtract these two. So what we are going to do is, this is A, this is B. We subtract the position vector of B and position vector of A. So we just copy this down. That is I plus 3J plus 2TI minus TJ. Actually copied A first. This should be B. So B is 5I minus 2J, and we multiply this T, that gets TI plus 4TJ, that is B, and we subtract all of this, that is I plus 3J plus 2TI minus TJ. So when we simplify, this is 5I minus I gives me 4I, then 2J minus 3J will give me J, and then I have TI minus 2TI will give me minus 3TI, and 4 minus minus plus, that gives me 5TJ. And let's compare if we get the same answers. He is making I the subject, so when we bring these two together, this becomes 4 minus 3T and I, and for J we bring these two together, minus 5J, yeah, thank you. So this was minus 2 and minus 3, so minus 5. So this is, when you bring this common, this becomes minus 5 and 5TJ. B part shown. C part says show that the two ships do not collide. So C part says show that the two ships do not collide. We have already solved for RB minus RA, and we'll equate it to 0. And 4 minus 3T I plus minus 5 plus 5TJ is equals to 0. And 4 minus 3T, if I substitute this, and I'm getting 3T time is 4 by 3 hours, and on the other side, that is minus 5 is equals to 5, T is equals to minus 1, which is rejected. Now if we have the time 4 by 3, we can see at time 4 by 3 what is the location. So when we substitute this 4 by 3 in the initial equation, which was I plus 3j, and I'm multiplying it with 4 by 3, so 4 by 3 into 2 is 8 by 3i and minus 4 by 3j, and simplifying 1 plus 8 by 3 is 11 by 3, and 3 minus 4 by 3 is 5 by 3. So this is the position of A when time is 4 by 3. Now we're checking for position of B. So we substitute this t as 4 by 3 and we get 5i minus 2j minus 4 by 3i, and 4 4 is 16 by 3j. So 5 minus 4 divided by 3 is 11 by 3i, and 16 by 3 minus 4 by 3, 16 by 3 minus 2 as 10 by 3. So we're getting a different position, so they do not collide. D part says find the distance between A and B at 10 a.m. So they started at 8 a.m. and 8 and 10 is 2 hours difference. So at all times we have this equation, distance between RB, RA. So if we use this and use the time as 2, so this will be 2 minus t is 2, that is 6, I minus 5, this is 10j. So distance is we'll find the magnitude, that is minus 2i, and this is 5j, so 2 squared plus 5 squared whole square root. So 2 square plus 5 square square root 29 is approximately equal to 5.38 kilometers. .385 is equal to 5.39. With position vector 12i and 12j, the initial velocity of A is this. So we have the initial position and we have the initial velocity, and it has constant acceleration. Another particle B initially, let me change this, another particle B initial velocity is this, acceleration is this. After 3 seconds the two particles collide. Find the speed of the particles when they collide. So for particle A, we have the initial position, we have the initial velocity, and we have the acceleration. So if I use v equals u plus at, initial velocity is minus I plus j, and acceleration is given, which is 2 minus 4, 2i minus 4j, and time is 3 seconds. So they collide after 3 seconds. So speed of A after 3 seconds would be minus I plus j plus 3 2 times is 6i, 3 4 times is 12j, so 5i minus 11j. When they collide, speed of A would be this. And for speed of B, velocity of B is equals to u plus at. So initial velocity of B is I, acceleration is 2j, and time 3 seconds later is this. So for speeds we needed 5 square plus 11 square whole square root is 12.1 meters per second, and speed of B is 1 square plus 6 square square root 37, that is 6.08 meters per second. And position vector when they collide. Okay, second part says the position vector of the point where the two particles collide. So they collide after 3 seconds. So r is equals to r naught plus vt. Initial speed of a is given minus I plus j. We have done the final speed in the previous part, that is 5 minus 11 plus 5i minus 11j and divided by 2 for average speed. So 5, that is 4 by 2 is 2i, minus 11 and positive 1 is 10 by 2 minus 5i minus 5j. So initial position is 12, velocity is 2 and minus 5, time is 3 seconds. So 3 2 times 6, 6 plus 12 is 18, and 3 5 times minus 15 and 12 minus 3. So it is 18i and minus 3j. C part, the position vector of B's starting point. The position vector of B starting point r is equals to r naught plus vt. So we know that the final position is 18 minus 3 because that is where they hit each other, and initial position is unknown, and we again have the acceleration. So for the final speed, v equals u plus at. We have the final speed in the previous part. So I plus I is 2i, and 0j plus 6j is 6 by 2. That will make it I plus 3j. The velocity is 1 3 and time is 3. So 18 minus 3, 3 1 times 3 minus 3, 3 3 times 9 minus 9. So 18 minus 3 is 15 and minus 12. So initial position must be 15i minus 12j. Let us check the answers. Exercise 3D, 15i, 12j, 18 and 3. Now all answers are correct now.